Hey everybody, in this video we're going to be talking about the unit circle. Now I'm not going to be testing you on the circle itself, and I actually might not test you on very much from this at all. But if you ever do some digging on trigonometry, you might see some concepts or some answers to, if you do sine of a certain angle, you will see some answers that some are positive, some are negative. It's different for sine and cosine and tangent, and it's all weird. So I'm going to explain when those answers are going to be positive, when those answers are going to be negative for sine and cosine and tangent, and the best way to explain it is using the unit circle. So a unit circle is just a circle with a radius that is this length right here, from the center to the outside, being 1 unit. So whatever you're measuring in. So it could be meters, could be centimeters, could be kilometers. I don't really care. But as long as it's 1 unit. All right. Now, if you notice, I could say, let's say I draw a line right here. Okay. I draw a line like that. And then from this point where it meets the circle, I draw a line straight down. All right. Now this line makes a right angle with the x-axis, right? So I've got a little mini triangle in here, and I've got some angle theta. So I could actually use my trigonometry knowledge, my sine, cosine, tangent kind of stuff, to figure out the coordinates of that point, right? Now we know the hypotenuse is 1, right? We know this length is always 1. From the center to the outside is always 1 unit. So we know this length. And if we measure these two lengths, well, if you notice, cosine of theta is, let me just label these. I'm going to call this, for simplicity's sake right now, I'll call this opposite and adjacent. Okay? Now if you notice, this point is some distance away from the y-axis, as in it's moved some direction, some number of units in the positive x direction. How many units? Well, if you look, it's the same as the length of the adjacent side, right? Now cosine of theta is adjacent over hypotenuse, but the hypotenuse is just 1. So really, in this case, cosine of theta is just adjacent over 1, or the length of the adjacent side, which means the x-coordinate of this point up here is simply the length of the adjacent side, which is the same thing as cosine of theta, right? Now similarly, the y value, the distance it's moved up from the origin, so the distance is moved up from the x-axis, is the length of the opposite side, right? Now if you look, sine theta is opposite over hypotenuse, but here, once again, the hypotenuse is just 1. So we're left with opposite divided by 1, that's just opposite. So sine theta is also just the length of the opposite side, while cosine of theta is the length of the adjacent side, right? In this particular case, you need the hypotenuse to be exactly 1 for this to be true and for this to be true. All right, but if you look, this point, its x-coordinate is whatever this length right here is, and this length is the length of the adjacent side. So I could just write that as cosine theta, and then its y-coordinate, the direction it's moved up off the x-axis, is just the length of the opposite side, but the length of the opposite side is just sine theta. So I can write cosine theta, sine theta. And the thing is, that might seem like a complicated way of describing this point, but so far we've only talked about angles that are between 0 degrees and 90 degrees. We haven't really worried about anything larger than that. What if my point was over here? What if my point was down here or over there? This point could be anywhere on the circle. This will always be true. All right? Now here's the thing. You can use your unit circle to know when your cosine value will be positive. So basically, if I give you the angle, you will be able to tell me if your cosine value is positive or negative for that value. And you'll be able to tell me the same thing for sine and for tangent. All right? Now, let me get rid of all of this stuff over here. Let's just think about it. If you look at, let's say, this point over here, this one right here, in the second quadrant. So this one over here is the first quadrant. This one over here is the second quadrant. Down here is the third quadrant. And over there is the fourth quadrant. So let's say we're looking at this point over here. You can see that we've moved from the origin, from the middle, we've moved in the negative x direction, right? So this length is going to have a negative sign stuck in front of it. All right, but we're still moving up. So this is still in the positive direction. It's just that the horizontal motion is in the negative direction now. All right, so if we're describing this by cosine theta, sine theta, you can see that because we've moved in the negative direction to get to over here, this value, cosine theta right here, must be negative for any angle between 90 degrees, which is up here, and 180 degrees, which is over there. We always start measuring with 0 degrees in the positive x direction, and then we start counting this way. So this is 0, 45, 90, 135, 180, and so on. All right? So for any angle in this quadrant, you have to move in the negative x direction, but the positive y direction to get somewhere on the circle here. So that means that your cosine value is always going to be negative in this quadrant, and your sine value is always going to be positive in this quadrant. All right, now if we look down here, we've moved in the negative x direction to get down this way. We've moved in the negative x direction, and we've moved in the negative y direction. Both of these are negative, right? So if we're describing this point, once again, by cosine theta, sine theta, both of these must be negative if you're in between 180 degrees and 270 degrees. So if you're anywhere down here, your cosine theta value and your sine theta value will be negative. So if your angle was something like 200 degrees, well, that's between 180 and 270, so you know that cosine of 200 will be negative, and sine of 200 will be negative. And then lastly, over here, to get to this point, we have to move in the positive x direction, but the negative y direction. So, once again, let's label this point cosine theta, sine theta, and what we get is that the cosine theta value, that first value, will be positive, but sine theta, because we're moving down, will be negative. All right, now let's see. So we've got up here cosine and sine are both positive, right? I'm going to get rid of this whole mess and leave just the graph, just the axes rather. So up here in the top right, in quadrant 1, we know that cosine is positive and sine is positive, right? In quadrant 2, we can see from right here that cosine is negative, but sine is still positive. So we've got cosine is negative, sine is positive. All right, down here in quadrant 3, both of them are negative. So cosine is negative, and sine is negative. And over here in quadrant 4, cosine is positive and sine is negative. Now there's one more thing to this. We haven't talked about tangent at all. So tangent, well, we know tangent from our last lesson. Tan theta is equal to sine theta over cosine theta. All right? Tan theta is equal to sine theta over cosine theta. Now if sine theta and cosine theta are both positive numbers, that's like 2 divided by 3. That's always going to be a positive number. I'm not saying that sine and cosine are 2 and 3. But if you're dividing a positive number by a positive number, then you're going to get a positive number. So tan is also positive in quadrant 1. In quadrant 2, though, if we take a positive number and divide it by a negative number, if either one of those numbers is negative, then your answer is going to be negative. So sine, like 2 divided by negative 3, for example, you can't get those numbers here, but if your if your x value, or if your numerator in your fraction, you're trying to do your numerator and denominator, if your numerator is positive and your denominator is negative, your answer is going to be negative. So tan is negative in quadrant 2. Down here in quadrant 3, though, both of them are negative. So it's like taking -1 and dividing it by -1. You're basically canceling it out. You could cancel out the 2 negative signs, which means that down here, tan is positive. As in, if you did -2 divided by -3 is a positive number. Okay? And over here in quadrant 4, I'm going to move the 4 over. In quadrant 4, we've once again got the same thing going on as quadrant 2, where you've got one of them is positive and one of them is negative, so your answer is going to be negative. Now if you look, up here all of them are positive, over here only sine, right? So I'm going to put an A for all in quadrant 1. All of them are positive. Over in quadrant 2 only sine is positive, so I'm going to put an S. Over in quadrant 3, only tangent is positive, so I've put a T. And over here in quadrant 4, only cosine is positive. That might look like a positive sign, that's a negative sign. And so the way you can remember this, the way I was taught in school, is if you start down here in quadrant 4, it spells out a word. It spells out the word cast, C-A-S-T. And so this is called the cast rule. Basically, if you start in quadrant 4 and then go anti-clockwise, you can figure out what's positive and what's negative where. So if I gave you an angle of 169 degrees, if you can figure out what quadrant it's in, and I ask you, is sine of 169 positive or negative? Is cosine positive or negative? Is tangent positive or negative for that angle? You should be able to tell me. If I gave you something like 323 degrees, you just need to be able to figure out which quadrant that's in, and you can give me an answer. Now remember, we start measuring with 0 degrees here, and then we rotate this way. This is 90 degrees up top. Keep going, this is 180 degrees over here. Keep going down there, this is 270 degrees. And then go all the way, and you're back at where you started, 360 degrees, full circle. All right, so you can use that as a gauge for where this is. Well, 169, well, that's between 90 and 180, so it must be somewhere in here. So sine of 169 will be positive something, I can't tell you what. Cosine of theta, cosine of 169 and tangent of 169 will be negative. All right, and for 323, that's between 270 and 360, so it's somewhere over here. So sine of 323 is negative, cosine 323 is positive, and tangent 323 is negative. So that's how the unit circle works. In our next lesson, we're going to talk about some specific angles and the sine, cosine, and tangent values of those angles. And they're not the nicest of numbers, but they're nice enough numbers that you should memorize them. So next class, we're going to be memorizing some numbers. All right, see you then.